This is section 1.5 and 1.6. I want you to take a minute to read over the definition of intervals of increasing, decreasing, and constant. So take a second, pause the video, read over this, make the connections, and then pick up from there. Quickly, I'm going to take a minute. This is the decreasing in red from -9 to -6. Constant interval from -6 to 5. And the increasing interval is from 5 on to infinity. Determine any relative maximum or minimum of the function and the intervals on which the function is increasing or decreasing. They give us our function value and the graph of it to the right. The first thing they ask is does the function have a relative maximum or minimum? This graph has a maximum because the vertex point occurs at a maximum value on top. So we're just going to say maximum. It says, and where does it occur? The maximum occurs here, which is going to be at the x equals 5.5. That's where our maximum occurs, the x value. And it has a y value of, what's that, about 7.25. So the max occurs at 5.5 and has a y value of 7.25. An example of a graph that would have a minimum would be one that's like this. That is considered a minimum. And any graph that has a maximum, the vertex is on top, this is a maximum value. So determining min and max is fairly simple. It says on what interval is the function increasing. So I want to know as I read left to right, where is it going up? So if I start here and I go left to right, it goes up all the way into this point. So I need to describe from here to here and left to right using my x values. So negative infinity, it's going to be negative infinity, and it increases, goes up all the way till I get right here. So it stops at when x is 5.5. And I can never use brackets. I have to always use parentheses when doing interval of increasing and decreasing. My next question, it says on what interval is it decreasing? So as I read left to right and go over this graph, I want to know when do I start going down. Decrease means down right here. So from this point on I go down, so I need to describe. This is 5.5 and it goes down forever because of this arrow. So my decreasing value is going to be from 5.5 to infinity. And when we're describing the increasing and decreasing, remember we're doing these values are the x values because of the domain of it. Next, we're going to look at the algebra of functions. We can add, subtract, multiply, and divide. We're just going to do a few of these. The first thing I'm going to do is show subtraction right here. So I'm going to write f minus g of x. I take my f, which is the x squared plus 2x. I'm going to subtract the g of x function, which is 3x minus 2. To do that, we can't forget that we have to distribute, so we get x squared plus 2x minus 3x plus 2, and then we want to add like terms right here, so x squared minus x plus 2. In the practice domain, we said domain of all functions is going to be all real unless we had our two exceptions. Remember our two exceptions if they had a variable in the denominator or if there was a variable under the radical. And since that's not the case, our domain is going to be all real numbers for this function. Next we have f times g of x. So I take f and I multiply it times the g function, and I have to FOIL this out. First, 3x to the third, outer, that's going to be minus 2x squared, inner, 6x squared, and last, that's FOIL, minus 4x. Add like terms in the middle, so you get 3x to the third plus 4x squared minus 4x. And this is going to be our solution, and once again our domain is going to be all real numbers. And we're going to evaluate the next one, f divided by g. So I take f, x squared plus 2x, divided by g. And there's nothing I can do to simplify that. But whenever I go to do my domain, I see that there is an x in the denominator right here. When that happens, we said we have to take our denominator, 3x minus 2, and set it not equal to 0 to solve. So that gives us 3x is not equal to 2. Divide both sides by 3. And our domain is that x cannot equal 2/3. So this is our function, represented by f divided by g of x. And this is our domain of that function. Next, we're going to talk about composition of functions. If you take a minute and pause it, read through this definition, we're going to be using this right here. So the first problem they say find the f of g of x, and then we're going to find the g of f of x. So we're going to do two parts. First, we're going to work with this f of g of x, and I'm going to rewrite it using this format. So I'm going to say f of g of x and work from the inside out. So if I work from the inside, I start with my g of x, which comes from right here, 3x minus 5. And so now it says go to the f function right here, and then everywhere x is at, I'm going to plug in 3x minus 5. So first of all, I'm just going to go write down the f of x equation. And then now everywhere x is at, I'm going to substitute this value in place of x. So I'm going to substitute that in everywhere x is at. So I have 2, 3x minus 5 plus 1. Distribute, minus 10 plus 1, 6x minus 9. It's going to be our f of g of x. Now on the other side, the second part, they ask us to do the g of f of x. So that's going to be g of f of x. And we work with the inside first, so we need to know what is f of x. F of x is this 2x plus 1. So I'm going to put in 2x plus 1. I bring down g. Now I stop right here and I say this is asking me go to the g function, which is here. Write it down. Let's go write down the g of x. 3x minus 5. And now they're asking me to substitute this value in place of x in this next equation. So everywhere x is at, I'm going to replace it with that. So now I have 3 parentheses. I put my highlighted version in, my substitution, and everything else stays the same. Distribute, plus 3, minus 5, add like terms, 6x minus 2. So that's evaluating composition of functions. You're going to follow this definition and break it into two parts and solve those two parts. So pause that, look over it, and make those connections on those two items.